Hello friends, welcome back to Positive Approach. This is Nitesh Bhardwaj. Today we will going to discuss about our unit number 4, which is work, power and energy. First of all, we will discuss about some important key point as usually, and after that we will proceed toward our numerical. So without wasting any time, let's start. Our first key point is work. Work is given by W is equal to F dot S. That is, it is given by dot product of force and displacement. So work done is a dot product. Work done is a dot product and work done is a scalar quantity, and dot product of F and V is also called power. Power is also a scalar quantity and it is given by the dot product of force and velocity. It is given by dot product of force and velocity. So work done is also a dot product, power is also a dot product, and dot product of magnetic induction B with area A is equal to magnetic flux. Magnetic flux phi B is equal to dot product of magnetic induction and area. This magnetic flux is also a dot product, and all these quantity work, power and magnetic flux are scalar quantities. These are scalar quantity. Now what is dot product? Dot product is commutative. For example, let A and B be the two vector, then the dot product of vector A and B is given by AB cos theta. A dot B is given by AB cos theta. If two vectors are parallel to each other, for example, if two vectors are parallel, then A and B, the angle between them is theta is equal to 0. If two vectors A and B are parallel to each other, then angle between them is 0. Then this dot product A dot B is equal to AB, because cos theta cos 0 is 1. And if these vector A and B are perpendicular to each other, then their dot product is always equal to 0, because cos 90 degrees is 0. So this dot product is 0. What does this imply? This implies I unit vector dot j unit vector is always equal to 0. J unit vector dot k unit vector is always equal to 0. And when these vectors are parallel to each other, what does this implies? I dot I unit vector is equal to 1. J dot j unit vector is equal to 1 and k dot k unit vector is equal to 1. I hope this is clear to you. Our next important key point is, what is projection? Projection of vector A is the direction of B is given by projection of vector A in the direction of B is given by is equal to the dot product of this vector divided by magnitude of B, and projection of vector B in the direction of vector A is given by A dot B divided by magnitude of A. Projection of vector A in the direction of B is given by P is equal to dot product divided by the magnitude of B. And if the projection of vector B in the direction of A, then it is divided by magnitude of A. I hope these key points are clear to you. Now work. We know that what is work? Work is the dot product of force and displacement, and it is a scalar quantity. Yes, it is a scalar quantity, and the dimensional formula of the work done is given by mlt minus 2. This is the dimensional formula of force, and dimensional formula of displacement is L. Then the dimensional formula of work done is given by ml square t minus 2, which is equal to Newton meter. And in CGS system, its unit is, the unit of work done is erg, and in SI system unit of work done is joule, and 1 joule is equal to 10 raised to power 7 erg. Keep in mind, 1 joule is equal to 10 raised to power 7 erg, and this is the dimensional formula of work. We know that work is a scalar quantity. It is the dot product of force and displacement. Its CGS unit is erg, and a SI system is unit is joule, and 1 joule is equal to 10 raised to power 7 erg, which is also equal to 10 raised to power 7 dyne centimeter. 10 raised to power 7 dyne centimeter. I hope this is clear to you. And work done. Work is of three types: positive work done, zero work done, and negative work done. What is positive work done? We know that the work done is given by this expression F dot S, where F is force and S is displacement. Okay, now what is positive work done? What is positive work done? If the theta is equal to 0 between this force and displacement, what does this implies? This implies if force and displacement are in the same direction, then the work done is positive. For example, when we pull a roller toward us, for example, like this is a roller, we pulled this toward us, force is applied toward this side and its displacement toward this side. The force and displacement toward same side and angle between them theta is equal to 0, then this work done is called positive work done. Let us take another example. When a body falls under the effect of gravity, this body falls under the effect of this gravity, because it displaces toward this direction and the force of gravity F is equal to mg toward also this direction. So this is also a positive work done. And when we pull a spring toward this direction, then its displacement and force toward this direction. So this is also the example of positive work. I hope this positive work done is clear to you. Now our second work done is zero work. What is zero work? When the angle between them, force and displacement, is equal to 90 degree. For example, when the angle between this force and displacement is 90 degree. For example, when a coolie holds suitcase on head but moving toward this side. For example, let this be a coolie and here this is a suitcase. It moved toward this direction but the force applied toward this direction. So there is the angle between 90 degree. Then we know that F dot S is equal to Fs cos theta. Okay, now this cos theta angle is 90 degree, cos theta 0, then work done is equal to 0. That's why when the angle between force and this displacement is 90 degree, the work done by any object, any coolie, is equal to 0. When the work done is 0, when the angle between force and displacement is 0. For example, work done by centripetal force always 0. Work done by centripetal force is always 0. Now our next type of work done is negative work done. What is negative work done? What is negative work done? When the angle theta is equal to 180 degree between force and displacement. For example, when we apply a force toward this direction, but displacement is toward this direction, then the angle between them is 180 degree. Then that case work done is negative. For example, when we throw an object, let this will be a ground, this is ground, when we throw an object toward upward direction. Okay, when we throw an object toward upward direction. Okay, here displacement is toward this direction. Here displacement of object is toward vertically upward, but the force applied here is mgh force, gravitation act vertically downward direction. So but its displacement is vertically upward. So there is the angle between this force and the displacement is 180 degree. So this is the example of negative work done. Let us take another example of negative work done, that is force of friction. Because force of friction always act opposite to that of its displacement. For example, let this will be a object, it moving toward this direction, but the force of friction will be toward this direction because it opposes its motion. So there is the angle between this displacement and this force is 180 degree. So this is called negative work done. I hope this positive, zero and negative work done is clear to you. Our next key point is work done by force is equal to area under force and displacement. Work done is given by the graph of area under force and displacement. Work done is expressed as the area under force and displacement. And as we earlier discussed, area under force and time is represent what? The area under force and time is represent impulse. Yes, it represent impulse. Now back to our topic. Our next key point is positive work accelerate the body. Positive work accelerate the body and it increases velocity. Positive work when theta between force and displacement is 0, that is force and displacement is in the same direction, then that work done is called positive work done. This positive work done accelerates the body and it increases velocity. Our next key point is the sum of work done on a body against the force of gravity, that is mgh. Okay, that is mgh. The work done on the body against gravity and the work done on body by the force of gravity, that is when object falls freely under the effect of gravity, this is always equal to 0. Work done on the body against gravity and the work done on the body by the force of gravity is always equal to 0. Our next and important key point, when body moves with constant velocity, when the velocity is constant, then the work done is always equal to 0. When the object moving with constant velocity, then there is 0 displacement, then the work done is always equal to 0. What is mechanical energy? Mechanical energy is the sum of the kinetic energy and potential energy, and this mechanical energy is also a scalar quantity. I hope all these key points are clear to you. Now let's discuss some numerical on the basis of these key point. Our first numerical is, so that vector A and B are perpendicular. Vector A and B are perpendicular. What is vector A? We know that when the two vectors are perpendicular, if their dot product is 0, if the dot product of two vectors is 0, then they are right angle to each other. Now what is A dot B? Here vector 2i minus j unit vector plus 2k, dot product of 2i unit vector plus 2j unit vector minus k unit vector. This is equal to I dot I is equal to 1, then this is 4, I dot j 0, I dot k 0. Now minus j dot 2i vector, this is 0 because we know that j dot I always equal to 0. Now j dot j equal to 1, now this is minus 2. Similarly 2 minus 1 minus 2, which is equal to 4 minus 4, which is equal to 0. The dot product of these two vectors, here dot product of these two vectors is equal to 0. What does this imply? This implies vector A and B are perpendicular to each other. I hope this numerical is clear to you. Our second numerical is, find the projection of vector A in the direction of B. Then we know that what is projection of vector A in the direction of B? Dot product of this vector divided by magnitude in the direction of B. Magnitude of B. Now dot product of these two vectors, where A is I minus 2j plus 2k and B is, and the magnitude of B is 2 2s are 4 plus 1 and dot product of A dot B 1 into 2, 2 minus 2 plus 2, 2 cancel, which is equal to 2 divided by under root of 6. This is the projection of vector A in the direction of B. What is projection P? That is equal to T divided by under root of 6. Where is the numerical? I hope this numerical is clear to you. Our next numerical number 3. Calculate the work done by the force. Force vector is equal to 2i plus 3j minus 5k Newton. Acts on a body. Produce displacement. Displacement vector is given by 2i plus 4j plus 3k meter in the body. Then we have to calculate work done. We know that what is work done? Work done is a scalar quantity and it is the dot product of force and displacement. Now we have to find their dot product, which is equal to 2 2s are 4 plus 4 3s are 12 minus 15, which is equal to 16 minus 15, which is equal to 1 joule. So this is our work done, that is 1 joule. We know that the unit of joule in SI system is joule and in CGI system it is erg, and we know that 10 raised to power 7 erg is equal to 1 joule. I hope all these numerical are clear to you. Now our next fourth numerical. A particle moves along x-axis from x0 to 4. Particle moves from x0 to x is equal to 4 under the influence of force. What is force here is 5 minus 3x minus 2x here. Newton. Calculate the total work done. Now we calculate this work done. What is work done? Work done is always a scalar quantity, implies x 0 to 4 into f dot ds. 5 minus 3x minus 2x square. This is our work done here, which is equal to, when we integrate, we can get 5x minus 3x square divided by 2 minus 2x cube divided by 3, and its limit is 0 to 4, which is equal to 5 into 4 minus 3 into 16 divided by 2 minus 2 into 64 divided by 3 minus 0, which is equal to 5 4s are 20 minus 2 1s are 2, 2 8s are 16, 24 minus 4 2s are 8, 6 2s are 12 divided by 3. And when we solving this quantity, we can easily get our work done. Every key point is clear to you and these numerical are clear to you. Tomorrow we will discuss about power, energy and this mechanical energy. Thank you and have a nice day.